Welcome to this explainer. Look, mechanical ventilation can feel like a tangled mess of dials and alarms, but today we're cutting straight through the noise. We are focusing intensely on the modes. We're going to use a dead simple, overarching framework to make total sense of exactly how the machine and your patient interact. Let's dive in. Here's our roadmap for today. We're hitting the core mental model, comparing full control volume versus pressure, mixing breaths in SIM-V, looking at assist control, and finally, CPAP. We are systematically walking from full machine control right down to full patient effort. Section 1. The core mental model.
Before we even touch a dial, you have to know the absolute golden rule of ventilation modes. It all comes down to answering two critical questions. Who starts the breath, and what is being controlled? Seriously, ask yourself, is the ventilator triggering this breath, is the patient pulling it, or are they working together? Once you nail down who initiates the whole thing, you just look at what the machine is trying to control. Keep this exact framework in the back of your mind as we go through every single mode today.
Moving on to Section 2, full control versus pressure. Let's start with control ventilation, where the machine is doing literally all the work because the patient has zero spontaneous effort. When the machine is running the entire show, we basically have two main options. Think of volume control, or VCV, as delivering a very specific package. It's a set volume of air, period. On the flip side, pressure control, or PCV, acts a lot more like inflating a balloon to a specific tightness. You're either prioritizing a strict volume or a strict pressure. It's one or the other. And that brings us to the ultimate trade-off. This is absolutely crucial. In volume control, the ventilator guarantees that set volume package. But because human lungs are dynamic and constantly changing, the airway pressure is going to fluctuate based on lung compliance. Now, switch to pressure control. And the pressure is guaranteed, but the volume absolutely is not. If those lungs suddenly get stiffer, the volume of air delivered drops. Simple as that. So in volume control, you're dialing in your tidal volume, respiratory rate, FiO2, PEEP, and flow. The machine has one job here. Give that exact package of air, no matter how much airway pressure it takes to push it in. It's stubborn like that. Conversely, in pressure control, your targets totally shift. Now you're setting the inspiratory pressure and time, alongside your rate, FiO2, and PEEP. Because the machine cuts off the flow the exact second it hits that pressure limit, the actual volume fluctuates breath by breath. Stiffer lungs, they're simply getting less volume. This perfectly summarizes our main clinical concerns. Because volume control will relentlessly push until that target volume is reached, your biggest nightmare is high pressure, causing barotrauma. You gotta watch those peak pressures. But in pressure control, since inspiration stops at that set limit, our main concern flips. We have to keep a super close eye on falling tidal volumes, which can rapidly lead to inadequate ventilation. Okay, but what happens when the patient starts participating and actually wants to breathe? As they wake up from anesthesia or get their strength back, we obviously have to move away from full machine control. We have to figure out how the ventilator adapts to their natural, spontaneous effort. Which brings us to Section 3, SIM-V, mixing breaths. Synchronized intermittent mandatory ventilation. I like to think of SIM-MV as a roommate agreement. It's a true mix of spontaneous and mandatory breathing. The ventilator has its scheduled mandatory chores, a guaranteed number of breaths. But your patient is completely free to put in some extra work and breathe on their own right in between those cycles. For example, if you set the respiratory rate to 12, the machine guarantees 12 breaths a minute. But hey, humans aren't clocks, right? If the patient wants to take breath number 13 or 14, they totally can. The machine will offer a little bump of pressure support just to help overcome the resistance of the breathing tube, but it is not going to force a massive, full mandatory breath on them for those extra efforts. Now, you might be wondering, what if a patient is trying to breathe, but they are just profoundly weak? What if we actually want the machine to fully support every single breath they initiate, not just the scheduled ones? That takes us right to Section 4, assist control, where every breath gets help.
The absolute golden rule of assist control is as simple as it gets. Every breath gets full help. Whether the ventilator triggers the breath strictly on a schedule or the patient triggers it by just trying to inhale, the complete programmed ventilator support is delivered every single time. There are no weak, unsupported breaths here.
Check out the math on this one. If you set the rate to 12, and the patient only takes 12 breaths, the ventilator gives full support for all of them. But if your patient decides to breathe 18 times, all 18 of those breaths get that exact same heavy lifting support. AC provides a safety net minimum rate, but the patient's triggers can absolutely drive the total rate up, with the machine completely backing every single effort.
Finally, let's hit Section 5, CPAP, continuous positive airway pressure.
Imagine a balloon that is actually inflating and deflating all on its own. In CPAP, your patient must have an intact respiratory drive to even start the process. If they aren't breathing, this mode is not going to breathe for them. The patient is 100% in charge of initiation.
So, what's the machine actually doing then? Well, CPAP itself doesn't provide a mandatory breath at all. It basically just acts like a splint, holding the airway open with continuous positive pressure throughout the entire spontaneous breathing cycle. Your patient's own diaphragm is doing all the heavy lifting, pulling the air in and pushing it back out.
Which brings us full circle right back to our core mental model. If a patient is on CPAP, who starts the breath and what exactly is the machine controlling? I'll leave you with that thought to really test your grasp